So if we talk about Charles's law, okay, we have Jacques Charles and Joseph Louis Gay-Lussac. They noticed that there is a relationship between the temperature and the volume of a gas, okay? As temperature increases, so does the kinetic energy of the gas molecules. So as the molecules move faster, they exert higher pressure. So the volume of the gas will expand under this pressure until it reaches atmospheric pressure. Okay? Now, there's a particular reason for that. Okay? Which we're going to get into as we deal with this. Especially, it's good to keep this, like, this is not an inverse relationship now. This temperature and volume are linear, and they are, as one increases, so does the other. Okay? So Charles' law states that the volume of a gas varies directly with the temperature at a constant pressure and mass. Okay? So the equation we use is volume 1 is equal to volume 2, and set up as ratios, so volume 1 at temperature 1 is equal to volume 2 at temperature, or over temperature 2. Okay? Where T1 and T2 is temperatures in Kelvin. This is something very, very important, because this does not work with Celsius, where we get negative temperatures. Okay? And volume is in liters. So, for example here, we have a balloon that was inflated at 27 degrees Celsius and has a volume of 4.0 liters. If it is heated to 57 degrees Celsius, what is its new volume, assuming constant pressure? So we look at temperatures here. This is what we know. Okay, we have to do this conversion. So this would be a point, looking towards your 6-point mark here, is these conversions of temperature and the stuff that you know. What I would also like to see is what you don't know. And in this case, what you don't know is volume 2. Okay, here is your equation. Alright, and we have some substitution here. Okay, and finally, you've got your answer. Okay, and we need to know also that we need to be putting this in significant digits. Okay, and you guys need to be very confident in the way that you're manipulating these equations. If you have any questions about this, again, I'm going to do more calculations just like this, and I'm going to write them down. I'm going to talk through them. Those will come in later videos, okay? So, if I look at example 2 here, a sample of gas occupies 6.8 liters at 110 degrees Celsius. What will the final temperature be in Celsius when the volume is decreased to 5.6 liters? Okay, now, again here we have to do the relationship over to Kelvin. Okay, these are things that we know as the two different volumes. Okay, again I would like to see here, a little T2 equals question mark. This is what you don't know. You're going to have your formula, your substitution. Okay, now if you notice this time, temperature at point 2 is on the bottom, so you'd have to do a different type of manipulation here of your equation in order to work it out. And you'll actually see me manipulate these again in subsequent videos. Okay. In this case, you'd find out that the temperature is 315.5 Kelvin, and you take that temperature and you're going to minus 273.15 degrees in order to get the temperature in Celsius, which just so happens to be 42 degrees when we look at proper significant digits. Next video, we're going to talk about gases and the kinetic molecular theory, talking about combined gas law calculations.